Alright guys, what's up? DayDaddy here today, and in this video we are going to be looking at a new addition to the BenchDaddy GPU benchmarking suite. So I've already made a previous video in this particular topic, and we were looking at a couple of basically standard deep learning tests, and in this video we're going to build on that, and we're going to look at integrating LLMs. Basically, I've integrated some of the open source LLMs with Llama and made those available for testing as well. So just to recap, if you didn't see the last video, the initial tests, or the first part of this benchmark, the version 1, I guess I should say, just included everything in the standard deep learning tests folder, or all the things right here. So we chose, or I looked at ResNet to represent kind of the CNN architecture, the LSTM to represent the RNN architecture, and then looked at BERT to represent transformers. So just a couple of models to try to get a general sense of how well GPUs perform on those particular architectures. So now we have expanded that, or I've expanded that to add LLMs, and that's this Llama test directory here, which has all the scripts and all the things that are related to that. So we'll go ahead and hop in and explain how this works, what the output looks like, and just give you a rundown of how to actually use this. So before we go any further though, I just want to shout out to one of my viewers who sent me a Vocaster 1 audio interface. Super nifty. I'd never used anything like that before, but I paired that with the Rode PodMic. So hopefully the sound quality should be significantly better in this video and all the subsequent videos now. So I'm curious to hear your thoughts, especially if you've been listening to this channel for any length of time. What do you think about the audio quality? Is it better? Is it worse? Just give me your thoughts there, and I'll be interested to see what you guys think in the comments. Okay, with that said, let's go ahead and get into VS Code here. So all I've done in this case is I've just pulled down the directory, so you can see BenchDaddy here, and these are just all the relevant files. So here's the standard DL test with all of the BERT, LSTM, and ResNet. But for today, we're going to be focusing on the Llama test specifically. So I'll go ahead and drop that down. And briefly here, I'll go over the repository structure, and then I'll look at the actual files themselves, and then I'll go over the setup and installation, and then we'll run it just to show you guys how it works or looks like when it's running, and then that'll pretty much be it for the video. So we'll start with the repository structure here. So in the Llama test, we have the configuration file. So go ahead and start there. So I'll just open up the configuration file. And what you're looking at here is this test file is basically telling it where to look for prompts. So the way that I've set this up is with the test prompts file here. So I'll just kind of jump around a little bit where it makes sense. But so the test prompts file here is where I've listed out all of the prompts that I want or want to be considered when benchmarking a particular GPU or group of GPUs. And I tried when I was coming up with this to think about prompts in increasing difficulty. So prompt 1 would be the simplest, and prompt 5 would be the most complex. But I'm not exactly sure that's how it translates out. To be honest with you, the results certainly don't show that. But that was the intention. And maybe that was a bit naive, and you can just kind of think about this as 5 different prompts, if nothing else. But the prompt 1 is explaining what artificial intelligence is, and the purpose of this really is just to test the LLM's response on a simple common question, only generating a relatively small number of tokens. For prompt 2, I asked it to describe the process of photosynthesis in plants and how it supports the ecosystem by producing oxygen and glucose. So subjectively, I think you can kind of agree that this prompt is a bit more involved than some of the others. So or than the first. And again, this is just to make it give a more detailed response. And then we go to the next, which is provide detailed explanation of quantum entanglement, covering the EPR paradox, Bell's theorem, and how entanglement is utilized in quantum computing for teleportation of information. So, even more complex there. This is going a step further, and it's asking it to actually write a short story. So trying to get many paragraphs worth of text. That says, write a short story about how scientists who discover a new form of energy must face ethical dilemmas as governments and corporations fight over control of the technology. The story should include elements of suspense, character development, and moral conflict. So again, trying to go a step further. And then finally, this is a different structure of response. So in this case, we want to list and explain the top 10 most important breakthroughs in artificial intelligence in the last decade, focusing on both advancements in hardware and algorithms. So this is it should be a different type of response, maybe a bulleted response or something of that nature. So in any case, the responses were designed to kind of elicit different things from the model. And, I think it's up to you and up to your particular use case how well these fit. But the good news is I made this so that you can easily add or detract. So all you have to do is add another -prompt, and then whatever text you want as a prompt, and it will automatically factor that in or use that when evaluating these GPUs. So that is the main thing there with the test prompts file. If we go back to the original config, there's also test runs. So this is the number of times we want to run with each prompt. And then the data or the metrics are averaged over that number of tests. So for example, if we run 5 times on one prompt, then all of the metrics will be averaged over that number of runs for that particular prompt. The next is the volume flag. And this is kind of important because, especially if you're testing larger models, it may speed things up significantly if you have a volume on your machine, because otherwise, if you don't have this flag enabled, it will just go and be saved. Like the model will be downloaded and saved into the Docker container. So as soon as that particular run for that model and GPU combination is done, it will be discarded. And then you'll have to re-download that again if you're going to test that model, particularly with another GPU combination. So maybe you're testing with one GPU and then 2 GPUs and so on and so forth. And then you'll have to re-download that whole thing. And if it's a large model, that might take a significant amount of time and also resources. So if you don't want to deal with that, then you can enable the volume flag to true, and it will make a volume so that you can just basically reload that same model that you have downloaded. Now, another case is maybe you are working on a resource constrained system and you don't actually want to save all of these onto your drive. So in that case, you should set this to false, and that's not going to save any of the models. It might take a little bit longer, but it's not going to utilize as many system resources. So I tried to make sure that in either case, you kind of tune that to whatever you wanted. And then finally, the remove Ollama volume flag here is set to false. So basically that just means as soon as you're done with all the testing, do you want to remove the Ollama volume and like clear your drive back off. So maybe you're fine with the short-term utilization of your drive for all of these models, but you don't want it to be taking up space longer term, or you don't plan on using these models again. So you can just have it delete the volume, and it shouldn't cause you any like memory or storage issues going forward. So try to make those nice and as user friendly as possible. But if you have any suggestions here, please let me know. Another thing is, or I guess the two main things here are the list of the model list and then the GPU ID list. So basically what this is any models you want to test that are available in the Ollama library, you can put here, and it will iterate through each of these models and test them. So in this case, we have the 8 billion instruct 4-bit quantization, the 8 billion instruct 8-bit quantization, and then the 8 billion instruct just regular model at floating point 16. So, you know, not a whole lot to say here other than just you can choose as many or as few as you want, and it'll loop through all of them. And then below is a list of GPU, or the GPU ID list, and this is how many GPUs you want to actually test. So, for example, if you only got one on your machine, just having it set at 0 is fine. It'll take the first GPU that you have. But if you have multiple, like for example, I have 6, so if I wanted to test GPU 1 and 2, or I guess 0 and 1, I could put 0, and then I could change this to comma 1, or I could do more. I could do comma 1, comma 2, you know, etc., etc., etc. Another thing that I wanted to point out here is I made this so that you could test with GPUs, or sorry, with the CPU as well. So one of the things that is interesting, particularly about Ollama, is it's built on Llama CPP, where it's basically a wrapper around Llama CPP. And so maybe you want to use this for testing different CPUs. Like a lot of things one of the things that's really common right now is people are trying to use Apple Silicon, and they want that integrated memory, or sorry, I guess it's universal memory is a term that they're coining, but basically like the GPU and the CPU can access the same memory pool, or have access to the same memory space on your computer. So essentially your GPU has a bunch more memory that you can use, or I guess the neural net that's kind of integrated in the Apple Silicon is utilized. So anyway, you can, I guess I shouldn't refer to it as a GPU. But in any case, you can test that. So if you wanted to just look at one CPU versus another, you can set this to CPU. Sorry, I think this actually needs to be CPU, because this is a string. But in any case, I'm going to go ahead and update that too while I'm thinking about it. But anyway, you can test these different CPUs for performance. So I wanted to allow you to be able to test CPUs, because that's a big part of why Llama CPP is so interesting to a lot of people. So I integrated that as well. Okay, so that's the config. We talked about this log to CSV, or maybe we haven't. Let me just cover it one more time. But this file, basically what it does is when you have the log outputs, so what the tests are going to look like is they're going to look like a bunch of log files like this. It's going to go through, and if you want a more concise or better way to play around with it, it'll export it to a CSV, so you can look at it in Excel or with Matplotlib, or like making any kind of graphics that you want to kind of analyze this data, perhaps makes that a bit easier. And I made this for myself, so I figured I would include it in here for anybody else that wanted to use it. And I've already been able to test prompts. So the next, I guess, important thing is so there's the test model prompt here, and then there's the test all. So basically the test prompts is kind of the core, and then the test all is a wrapper around this script. So basically what this does, sorry, if we scroll all the way down here, it's going to test all the prompts. So what it does is for a particular model, so if you were to just run this by itself, it would default to Llama 3.1, and then it's going to basically go through and test all the prompts in the YAML file, and then it's going to test them X number of times. So test runs is set to 3 by default, but in our config we've upped it to 5. So, but it's going to go test all of those things, and it's going to average all those metrics, and then it's going to return those metrics in the form of a log file. And we'll see what that looks like here in just a second. But to make it more scalable, I wrote this test all. And also what this does is it tests each one in a separate Docker container. So that just kind of encapsulates things and makes the environment consistent when we're actually testing. So it goes through and it creates a Docker container for each of these models. and then only allows them to access whatever GPUs that you specify. So again, trying to encapsulate this and make this as airtight as possible. And then it goes through and it gives the GPU ID list, so however many GPUs that you want to actually test with, and then the test file, which is the basically the model, I believe, is what it actually is. Actually, what is the test file? Oh, sorry, that's the prompts. I guess I should have said prompt file, but in any case, that's the test file. The test file is the test prompts, I should say. And then the model names, or I guess the model name, we're iterating through the list here, and then the number of test runs. So in any case, all this does is it makes a container, it runs the tests with the test all prompts, the test model prompts, and then it stops and cleans up the container and logs all the results. So that's a pretty good overview of how everything works. Okay, now the next thing, or I guess the last thing that I want to do here is I just wanted to show you how you would run this. So let's go ahead and get into the Ollama test directory, make sure we're seeing all the right files. All right, so this is literally as simple as going through and going to the config file, and then iterating, changing the model list, and then if you wanted to change this to, like, I'm just going to make this simple, and we're going to test one GPU, and we're going to test these three, or I'm only going to let it run for one, but we're going to test these models with the default prompts and the test run at 5. So basically keep everything as it was as default. And then the next thing is just running Python test all .py, and it's going to create a Docker container. So again, Ollama, and it's going to name it the name of the model it's actually testing. And then if we want, we can also look at NVIDIA SMI, and we can check out and make sure that the model, so there we go, it's running on the first GPU, which is good. That's exactly what it's supposed to be doing. So it loaded, so let's see, it pulled the model successfully. It's waiting for the model to be accessible. So basically it's spinning that up in Docker container and waiting, it's querying the API and waiting for it to become accessible. And now that it's accessible, it's going to go through and it's going to test all of those prompts. And then so now we're just going to wait for it to test all those prompts. And then you should see a new log file output here. So I guess it already tested the first one. So what the output looks like, and I guess it's another thing we should talk about here, is what you're actually getting out of all of this. So running the test for prompt 1, and then the average metrics, so the total duration, load duration, prompt evaluation duration, response evaluation duration, tokens per second, and then it logs the GPU utilization by ID. So this, I just wanted to, so in case you're like running like multiple GPUs and you want to see like how each one is utilized during the test, I felt like that would be a pretty nice thing to know. Of course, you can always just use NVIDIA SMI while you're testing, but this puts it in a log format so you can go back and look at it later. And then I also wanted to include the example response. So this is important because just, if you want to understand the model testing from a prompt quality perspective, you could go back through and you could write a script to analyze the actual response itself for sentiment or for, all of it, whatever your particular, interest is, this would do that for you. Or this would give you the ability to go back and analyze that information. And then to explain a little bit further here, so the load duration in this case is how long it takes the model to load onto the GPU. The prompt evaluation duration is how long it takes to actually evaluate this particular prompt here. the response evaluation is how long it takes to actually generate this response here. And then the total is obviously all these added together. And then, you may notice if you add these together, I don't think it exactly matches this, but there's also some overhead involved with all of the stuff. So I think that overhead is also taken into account, but it should be really close as far as the total and all of these different pieces if you add them together. And then finally, the tokens per second. And this is, I guess, kind of the main benchmark, or the main way that I would assess things is this tokens per second. It seems like that's the metric everybody else uses to compare, which I mean makes sense. And this will also allow us to compare with the original standard benchmarks, because they also output a tokens per second as well. So, or I guess I should say it's a samples per second in that case, because not everything is in terms of tokens. But you guys kind of get the idea. It's a directly comparable metric, or at least a similar metric that allows for some comparison. I'm not going to say it's a direct comparison, because I think comparing between model architectures can be kind of tricky in that way. But in any case, I think this kind of so let me explain this a little bit better. So the tokens per second is calculated by the response evaluation duration. So basically how long it takes to generate the response versus the number of actual tokens, or the number of tokens generated. So that's the way that this is calculated. And this is taken directly from Ollama, how they recommend to calculate it. So, if you're curious and you want to see their documentation, you can also go to their website, and you can take a look. But it's the same way that they are calculating things as well. So just to show, let's take a look at some other prompts here. So it looks like for what is number one? So for the RTX 3090. It looks like we are getting about 97 tokens, 95, 98, 96. So call it maybe 96 and a half, 97-ish, somewhere in there for average token generation for that particular model. And then when we go to the Quant 8 version, we're getting about 70, 69, and we're not done with that one quite yet. But anyway, you guys get the idea. I'm not going to go through this whole test, but you guys get the idea here. And in fact, I'll just go ahead and stop this so I can show you the results of so we'll go ahead and stop that guy. And it should automatically clean up. Okay, so it cleans up the container automatically. Let's see. Well, whenever this program is shut down, it should clear that off as well. Let me go back, sorry, to here. The next thing I wanted to show is the log to CSV. So we have some log output. So now if we're in this folder and then we run Python log can't type today, log to CSV. So there we go. And this is going to give us summary. So the GPU IDs, the model name, the prompt number, the total duration. So all those things that we just saw, so that you can kind of easily compare, for a large run and make this a bit more scalable. Let's see. Yeah. Yep. So that's let me just show you guys a little bit easier. This is kind of hard to see. So let's go to command palette. And let's open preview. That's what I wanted. So there we go. So now you can see much more nicely. So GPU IDs. So it's just going to be GPU ID whatever _ whatever, and it's just going to list those out. And again, it's a little bit rough. You could clean it and make the data a little bit more ingestible. But the point is, it's easy at this point to iterate through it and make these changes and do kind of whatever you want with this data. So anyway, guys, that's pretty much it. I have as you can see, I've done a bunch of testing on this machine with different GPUs, and then I've also tested across several machines with some CPUs. So I'm going to make a video probably right after this comparing all those results if you're interested. So please check out that video. But that's it for today, guys. I really appreciate your time and attention, and I will see you guys in the next video.
All right, guys, brief reminder here. If you enjoyed the content, please consider giving me a like and a subscribe so I can continue to grow and produce better and better content for you. If you really enjoyed the content, you might even consider buying me a coffee, and the link for how to do that will be in the video description below. If nothing else, please just give me some feedback in the comments and let me know how I'm doing, if anything's unclear or if there's anything that I can improve on. Thank you again, guys, and have a great rest of your day. Bye-bye.